Professor Deb here with Technical Mathematics. Today this video lecture is going to be looking at logarithmic functions. Hopefully prior to this video you viewed the lecture video on exponential functions. And what we're going to be doing in this video is we're going to take logarithmic functions and change them into exponential functions, as we've already learned how to work with exponential functions. So let's learn how to change them back and forth. Let's get started. Here is the way a logarithmic equation looks like. A logarithmic function, I should say, because we're still talking about functions. F of x, okay, what that means is the function of x. And let me remind you what a function is. Every value of x gets put into here, into the equation, to change the answer. So we put all kinds of numbers in here, write the log of b, and we get an answer. That's a function, right? Now we want to look at what this part does. First of all, this is read log to the base b of x. And this refers to the base. Now, we're going to take a look at base of 10 and base of e, and we're going to change this value of x. First of all, we learned from the other video that we can change this logarithmic function, that when we set it up as an equation, y equals log to the base b of x, we can turn that into an exponential function which says x equals b to the exponential y. And this is what we're going to be doing, is going back and forth so that we can resolve the answer to these equations. So let's take a look at how that works. Here's two expressions, and we're going to change them into exponential form. Now, this particular one is a base of 9. Right here, a base of 9, okay? And remember, we said we would read that as log to the base 9 of 6,561 equals 4. So let's rewrite that, okay? If we say 9 to the 4th, well, that's our exponential form, right? 9 to the 4th. And if you put in 9 to the 4th into your calculator, you're going to find that 9 to the 4th equals 6,561. So that is how to rewrite it into exponential form. Okay, here's another one. A little bit tricky because it's got the darn fraction in there again. Okay, we're going to say that 3, this should be a negative right here. Sorry. We want that negative. Let me go back and explain. Why do we want that negative? Because this is a fraction here. And you'll see why in the explanation. I think my editor wasn't working very well again. Okay, 3 to the negative 5th. A negative exponent is going to put the answer in the denominator. So we have 3 to the negative 5th equals 1 over 243. When we have that negative number, that's the same thing as saying 1 over 3 to the positive 5th. We invert it for the negative exponent. So we have 3 to the negative 5th equals 1 over 243. That's how to convert it. All right, let's go the other way. Now we've got the exponential format, and we want to change that into a log format. Okay, we've got 4 to the third equals 64. How can we rewrite that into a logarithmic form? If we take log, and remember this is the base, so we put that as 4, log to the base 4 of 64 equals 3. Now digest that a little bit, then we'll go on to the next one. Here we have 125 raised to the 5/3. It's a fractional exponent. You may not want to work with that. So how do we write this into logarithmic form? We have the log again, and this is our base, 125 of 3,125 equals 5/3. Okay, so we're working with a very large base here, and we are able to get an answer. All right, try this one yourself. Stop the video and try and put this one in logarithmic form. Okay, hopefully you got that right. Check your answer with the guided solutions. Now, we want to talk about two different common logs. Now that we understand logs and where they come from, we want to identify some logs that we're used to working with in technical studies. And the first one is the common log. Pick up my pen here again. Okay. So when we write the word log, that refers to the common log. And these have a base of 10. Now, this is what we usually work with in industry. This is what we're commonly using as a base 10. Isn't all of our number system on a base of 10, right? 1 through 10, and then 11 through 20, and so forth. We work with a base of 10. So to designate that base, we just use the word log. That's referred to as a common log. And if we put in log of 78.143, find that log button on your calculator, put in 78.13, and you should get equals about 1.89. Now, on some calculators, you have to turn it around, so let me caution you, you'll have to work with your calculators. And this is a TI-84 Plus that I'm working with, 78.143, and then the button for log, and it will give you 1.89. So you just have to stop the tape and take a look at how your log button works. All right, let's go on now to what we call natural logs. These have a base of E. They're designated as ln. E we looked at a little bit before in another video where we talked about what this value of E was and how it was used in technical studies. So a lot of times we're using the common log, or we're using a base of E in doing many technical calculations. So we designate that with ln. And in this time, we're going to take the ln of 30.62. Again, you need to find the ln button, and it may just be ln on a TI-84, or it may be a button that says this, ln of x. So you should have one or the two of those. So put in ln or lnx, and then put in 35.62. And again, some other calculators reverse this. They want you to put in the 35.62 and then this button. But most of the calculators now work where you put in the ln button and then the value. And it should give you an answer of 3.573 or thereabouts. So that's working with the log button and the ln button. All right, now sometimes in industry we have different bases. Our most common bases again are the base 10 or E, which is the natural log. But some things in industry work with other bases that come into contact with electricity or other things that work with a different log. So we need to know how to work those. Now, many calculators, one of the higher TI-84s and the TI-Inspire and some of those calculators that you look at are able to work with different bases, and you can just put in log and then you enter in the base. But many don't, and I want to take a minute to show you what you could do if you have a different base. It's called the change of base formula, and how it looks is the log to the base b of x equals the natural log of x over the natural log of the base. So it's a double equation, but it allows us to work with that different base. So in this case, you would put in ln of 691.45 divided by ln of 8. And you should get approximately 3.14. Sounds like a familiar number. Just happened that way. You want to stop the video and take a look at how to put these in. So now we can work with, if your calculator doesn't have an automatic log with a different base, you can use the change of base formula. Try that. Stop the video and try and take a look at entering this base of 3 and coming up with a value for that. Take a look at the guided solutions to check your answer. All right, now again, we want to take a look at now a graph of a log function. Okay, so let's rewrite this. We've got this odd base again, and we know to use the change of base formula in order to do that. So what would this look like? ln of x over ln of 3. Now if you're putting that in your graphing calculator, it would say y equals, and this is what you would enter, ln of x over ln of 3. Okay, so I'm going to try and put that in here, ln of x over ln of 3. All right. Once again, we're going to take these values of x, because this is a function again. We're going to take these values of x and put it right in there. So you're going to do the first one, ln of 0.5 divided by ln of 3. And you should get a negative number about 0.63. And 0.1 should be negative 2.1. 1 should be 0. Remember when we were discussing exponential graphs in the earlier video, that 1-0 combination was an important one. So now we see, instead of crossing the x-axis in an exponential, we're going to instead of crossing the y-axis, we're going to cross the x-axis. And we're going to be going in the negative y and the positive y direction. So number 2, let's see, for number 2, I got about 0.63, and for number 3 I got 1, and for number 4 I got 1.26 and 1.63. You'll have to stop and verify all these numbers, but I think you'll get the idea of how the graph goes by looking at this selection. So we've got an x value of 0.5, and we're down here at negative 0.63, about there. And we've got an x value of 0.1, and we've got a y value of down here at 0.2. Come on. There we go. And 1, 0 is where it's going to cross. And 2 is up here at 0.63. And 3, that's nice, 1. Okay, so let's get our graph going. I think we've got enough points here that we can take a look at it. So it's ever decreasing again. Whoops, I shouldn't have touched that line. I didn't do a real good job of that. So it's ever decreasing closer and closer and closer to that y-axis, but never hitting 0. And then it exponentially increases. So if you'll remember, let me take a little second to remind you, exponentially we were doing like this, where we were going on both sides of the y-axis. In a log graph, we're going on both sides of the x-axis. All right? Thank you very much. Hope you enjoyed the video. Bye.